Hello students, welcome to my class. In today's class, we'll discuss rules for finding x in linear congruence. Ax congruent b mod n. This is the general format. Let me write first rules. What are the rules? How you are going to solve such examples by following these rules. Yes, first step, whenever you are given with the congruence Ax congruent b mod n, first you need to find GCD of what? A and n. Yes, this A and n. Let this GCD be D. Yes, just for our convenience, I am writing D. Yes. Next step, after finding GCD, we have to check whether B divides D. This B divides this GCD. If this is true, if it is possible, then we say solution exists. Yes. Next step, if it is true, then find D mod n. Whatever GCD you will get, using that to D mod n. Then whenever this happen, you do this D mod n, whatever number you will get, those are the possible number of solutions. So these are possible number of solutions. You get to know how many numbers solutions you are getting for the given congruence. Next, divide the congruence, given congruence, both side by n, both side by d. Whatever GCD you are getting, divide by that. Then after dividing, multiply both sides by multiplicative inverse of a. Yes, in the one of my previous classes, I have mentioned in the property what you mean by multiplicative inverse. So multiplicative inverse of a. Yes. What do you mean by this? Multiplicative inverse means a into a inverse gives you of x for this. For this equation, a into a inverse of x congruent to b into a inverse of mod n. Equation becomes like this. After that, we need to find the general solution equation as xk is equal to x naught plus k into n divided by d. Yes. Now, how you are going to find this general solution? Once you multiply A inverse both the side, you will get an equation in terms of x. Express this in terms of x like this: xk equal to x naught plus k into n by d. You have to substitute the k value to get the value of xk. But where k should be what? K values must be from 0, 1, 2 up to what? Up to d minus 1. Understand? We have to put k up to d minus 1. Suppose your d is 2. 2 minus 1 is 1. Then you have two solutions. Only 0 and 1. Understood? If your d is 3, then 3 minus 1. You can put the values k as 0, 1, 2 in this equation. Yes? So, and also one thing you have to observe, this one here only you come to know how many solutions you are getting: 3 solutions, 2 solutions. Depending upon that, you know how many values of k you have to put. After that, x value solution, whatever solution you will get x. You have to substitute values until you get x less than n. whatever n you have mod n. Yes, this n. This is the procedure to solve the given linear congruences. Yes. Let us see examples. Once and there are two ways to perform this. Find the value of x in a linear congruence. One by following this one, the rules. So we'll check. Solve 14x congruent to 12 mod 18. What is our aim? We need to find the solution. Yes. How many solutions does this equation have? Compare this with your general form. Ax is congruent to 12 mod 18. Yes. Now when you compare this, A is 14. Yes. Sorry, it is what? It is our B. B mod n. Yes. B is 12 and n is 18. Right? It is the first step. First step is to find GCD. Yes. GCD of what? A and n. 14 and 18. GCD of 14 and 18 is what? Greatest common divisor. Yes. It is 2. That is our D. Yes. First step over. Next. Second step. B divides D. Yes. We'll check that. What is our B? B is 12 is divided by 2. Yes. Equal to 6. X. Means what? It is true. So solution exists. If B is divisible by D, then you can move further. Yes. Then after that, D mod n. D mod n. What is our D? D is 2. 2 mod n is what? 18. So 2 mod 18. So 2 mod 18 is what? 2 only. Yes. Therefore, how many solution exist? 2 solution exist. Divide both side. Fourth step. Divide both side by D. What is your D? D is 2 here. So your congruence 14x divided by 2 is congruent to 12 by 2 mod 18 by 2. You have to divide for whole congruence. So it becomes 7x congruent to 6 mod 9. Yes. Once you get this, what is the fifth step? Fifth step, we have to multiply with the multiplicative inverse of A. So multiply with multiplicative inverse of A is what here? 7. Multiplicative inverse of A is 7. So 7 into 7 inverse into x is congruent to 6 into 7 inverse mod 9. Yes, 7 into 7 inverse is 1. So it is x congruent to 6 into 7 inverse of mod 9. Yes. Now we need to check what is the multiplicative inverse of 7. How we are going to check? We find multiplicative inverse of 7. How you are going to find? Let us, what is the multiplicative inverse? 7 into 7 inverse must be equal to 1. Yes. So we'll take that as a 7 inverse is C. So 7 into C mod n must be 1. Understood? Their product should be equal to 1. So now, what is our mod n now here? 7 into C, our n is 9. Yes, this is our 9. So mod 9 equal to 1. So we need to check for which value of C the product is divisible by 9 and remainder is 1. Yes. Go on putting the values. For C equal to 1, 7 into 1, 7 mod 9 is not equal to 1. Yes, of course. 7 is the remainder. When you put 2, 7 into 2 is 14. 14 is divided by 9. Whether that is equal to 1? No. When you put C as 3, 7 into 3 is 21. Is 21 mod 9 is what? Is not equal to 1. No remainder 1. Then put C as 4. When you put C as 4, it is 28 mod 9. When it is divisible by 9, 27. 28 minus 27. 9 is a 27. Remainder is 1. So, what do you mean by this? C equal to 4. When you put C as 4 here, so it acts as inverse of 7. Understood? Therefore, 7 inverse is 4 here. Therefore, x is equal to 6 into 4 mod 9. That is 6 is congruent to 24 mod 9 is equal to, when it is divided by 9, remainder is 6. Yes, it is 6 mod 9. What it implies? X naught is equal to 6. This is the initial solution. Now we need to find the general solution. Then general solution, what is the formula of equation is xk equal to x naught plus k into n divided by d. Yes. So x naught already you know. It's already it is a 6. Now put k as 1. For k as 1, it is 1 x1 equal to x naught you know, that is a 6 plus k is 1. N is what? N is 18 here. D is 2. So it is 6 plus 2 9s are 9. Yes. What is x1? X1 is equal to 6 plus 9 15. Since D is, as I said before, D is 2, you can put k value up to D minus 1. Yes, 2 minus 1 means 1. You can put k as 0 and 1 in the equation. Yes. If you don't want to do this, you can express it in x form, equation form, and this xk equal to x naught plus k into n by d form. Go on substituting k from 0, 1, 2. Here only you will get, when you put x k as 0 here, what happens? When k is 0, not in this, in the equation only. By inspection method only, you can find x as 6. Yes. We'll see one more example so that you'll understand it in a better way. Okay. Okay. Let us take solve 9x is congruent to 12 mod 15. Yes. We'll check this. So what is the first step? First step is to find GCD. Yes. GCD of 9 and 15. GCD of 9 and 15 is 3. It's a common number. Yes. Now, what it means? It means there are how many possible solutions? 3 possible solutions. For x, there are 3 possible solutions. So now, the congruence is equivalent to now what is the next step? We need to divide this by d. Yes, when you divide this by divide congruence by 3. So what we will get? It is 3x congruent to 4 mod 5x. You can write this as 3x minus 4 mod 5s, or we can write it as 5 divides 3x minus 4. What I want? I want 3x x. So or else 3x minus 4 equal to mod 5. You can write it as 3x minus 4 can be expressed as multiple of 5. Yes, some 5. Okay. Instead of the following that rules, you can write it in this way. Then what is x? X is equal to 5k plus 4 divided by 3. Now by inspection method, you can check for which value of k it you will get x value. Means this value is divided by 3. So we start it by putting k as 0. When you put k as 0, it is 4 by 3. It is not satisfied. So now we'll check it for 1. When you put k as 1, 5 plus 4 is 5, 9. 9 by 3 is 3. Yes. So when k is equal to 1, what is x? X is equal to 3. Therefore, x is congruent to 3 mod 5. So this is your first solution. Means what? This is your x naught. Now we need to find the general solution. The general solution is xk equal to x naught plus k into m divided by d. Yes. Now finding x naught is by inspection method only. Yes. After finding x naught, remaining values, possible solutions are find by this equation. Yes. Now here we have substituted k as 1. When you put k as 1, you got this value. You can take k as here, you can take k as instead of k, you can take any other value, any other notation. Yes. Now, when you put k as 0, when you put k as 0, what happens here? xk, xk is x not only s, that is 3. Yes. Now, the possible solutions are 3. Possible solutions are 3 means d is 3. As I said, you have to take k up to d minus 1. So 3 minus 1 means 2. So you can put k as 0, 1, 2. Yes, x naught we already know. So you can put k as 1 and 2 now. So when you put k as 1, x1 is equal to x naught, you know, that is a 3. Yes, plus k as 1. What is your m? M is 15. D is 3. So it is 3 plus 5, 8. Now put k as 2. X2, 3 plus 2. This is 15 by 3 only. S 3 plus 5 into 2, 10. It is 13. So therefore, possible solutions are x equal to 3, 8 and 13. So you will get, and one thing, as I said, your solution must be less than your m. What is your m? Here m is 15. For this example, m is 15. N or n, m, whatever you considered. So our solutions are 3, 8 and 13. And we came to know we will get only 3 solutions. Our 3 solutions, and these 3 solutions must be less than your your mod, here 15. Just see 3, 8 and 13 are less than 15 only. Yes, everything is satisfied. This is how to solve the given congruences, linear congruences. Yes, go on. We'll check one more thing. Solve 7x congruent to 9 mod 15. Now, what happens? 7x congruent to this one, GCD of 7 and 15. Yes, is what? GCD of 7 and 15 is 1 because they are co-primes. Yes, just by seeing you come to know. Then after this, then there is no because what it implies? It implies what are the possible solution? You have only one solution. Only one solution. And divided by d because it is 1, we'll get the same congruence only. Okay. 7x congruent to 9 mod 15. Yes. Automatically, you can write this as 15 divides 76, 7x minus 9. So, it is 7x minus 9 is equal to 15 into some k. And I want x. So, it is 15k plus 9 whole divided by 7. Now, by inspection method, you can check what is your x by putting k because anyhow we have one solution. Only by inspection method for what value of k the whole equation is satisfied. We have to check. Go on substituting k as 1, 2, 3, 4. Check whether it is divisible by 7 or not. When you put k as 1, it is 15. 15 plus 9, 24 divided by 7. Yes, it is not possible. So, when you put k as 12, yes, when you put, sorry, sorry, when we put k as 5, k as 5, you will get 84 by 7. Yes, so your x is 12. This is the only solution exist. So, whenever your GCD for in a linear congruence, whenever you will get a GCD as 1, yes, then it is easy to find the solution because you will get a only solution as 1. Yes, now to find the linear congruence examples in the next class, I am going to discuss Chinese remainder theorem and examples on that. Till then, keep practicing. If you have any doubts, comment in the comment box. Follow my channel, subscribe if you are not yet subscribed. Till then, take care. Thank you.